Hello, this is Kevin Bowersox, creator of the blog 2Thought. In today's tutorial, we will create some basic queries using Spring Data. To get the most from today's tutorial, I would recommend that you have viewed my previous posts regarding JPQL, or have a thorough understanding of JPQL. During this tutorial, we will define a number of methods on our repository interfaces that will allow us to query against our data model. The implementation of these methods is constructed by Spring Data as long as our methods follow a specific format. If you'd like to follow along with today's tutorial, you may download the code base for the tutorial by clicking this GitHub link on the Defining Query Methods on Repositories post. If you would like to view the completed code, you can click the GitHub icon underneath the post. This tutorial will strictly cover how to define interface methods that return Java objects that correspond with our data model. We will not delve into configuring Spring Data. That has been covered in a previous post, which you can view on my blog. And we'll bring that up quick just so you have a reference. That would be in the Configuring Spring Data with MySQL post. If you have not configured Spring Data, this tutorial will walk you through all the steps, and then you'll be on par with today's tutorial and can follow along. I would like to quickly review our data and object models before we begin. So we're looking at the 2Thought tutorial schema, which contains a comment table, a post table, and a post part table. The post table represents basically a blog post, while the post part table contains the actual article for that post. This is a one-to-one relationship with post. You'll also notice we have a comment table, which represents comments about a post. And I'd like to draw your attention to three columns within the comment and the post table. Those columns are the author, email, and created date. You'll notice those columns exist in both tables. And then when we look at our object model, you will see that we have created an embedded entity for those three fields, and we call that a stamp. So let's just take a look at stamp quick. There you see the author, email, and created date columns and fields being wired up via JPA. And we'll just take a quick look at comment to view that there is a stamp on comment. So we need to traverse those entities at some point. I just want to bring this up so you don't get confused during the tutorial if I have to reference stamp. It adds a level of complexity, but it also adds a level of reusability within our entity model. When working with Spring Data, one of the objects we commonly work with is a repository. I have defined a repository in previous tutorials for each one of the entities or tables that we've been using. Here you see the post repository, and we see that it extends the JPA repository, and it provides two generic type arguments, the type of entity and the type of its key. Once we have these, we can define methods on this interface that will allow us to query our object model. The JPA repository interface that we are extending is provided by Spring, and once we extend that interface and we properly scan for that interface, Spring Data can provide implementations for the methods we define to allow us to query the object model, as well as it provides the essential CRUD operations that allow us to insert, update, and delete entities. Now that we've set up the context for the work we're about to perform, let's begin by defining a method on this interface. And the method we'll define is going to pull posts by their title. So the post entity extends the abstract post, and here you see it contains a title. So to use our repository, we have to create an interface. We want to get a list of post objects, and then we need to use the method name to define what we'd like to pull. So each one of these methods will start with find by, and then we specify the attribute we would like to find by, and then we can provide some sort of other prefix on this method name that states the method in which we would like to find. I'm going to use containing, which is basically short for execute a like statement with wildcards around the parameter provided. We need to add a parameter to this method. So we add a string of title. I'm going to import list, and we've defined our first method. To test our method, I'm going to create a new unit test. Whoops. And I will call this unit test Spring Data Test. And I need to pull in some of the Spring Test configuration. As always, I'm going to steal this from another test we've defined. And then I'll give our test a name. And we need to auto-wire a repository. So this was the post repository. And we'll import those. And we'll grab a list of posts from the repository using our find by title containing method. I'm going to grab every post that contains Java. I'll import the list, and then we will iterate through the posts and print out the title just to show it works. Before we execute this test, I'm going to use the test-util class I've created. It's contained in the source code, and I'm just going to execute that. It will populate our database with some dummy data. And now I'm going to execute our test. And you can see we received a bunch of posts about Java. They all had the same title. That's how the test utility method populated the data. So we defined our first query method on our repository interface. Now let's explore how we can execute more advanced queries. I'm going to head back to the post repository where we will define our next query method. And in this query method, we would like to filter our posts by the author. So if you remember, we had the author within the stamp embeddable. So we need to traverse through that embeddable to get to the author field. To do that traversal, we specify the field on the post. In our case, it's on an abstract class, which is stamp, and then we specify the field we would like on stamp, and that is author. In this way, Spring Data allows us to traverse through nested fields. And now we'll provide a parameter, and we'll head back to our test. I'm going to comment out this test so we don't get all the console output. I'm going to create a new test method. And let's actually make this a containing, because, well, we don't need to. I think I know the name of an author. So we're going to get a list of posts. And then we use our find by stamp author method. And we'll get all the posts that I've created. Iterate through those posts. Get the author. And get the title. So let's execute our test. And we can see that we've returned all the posts that I have made by traversing through the stamp to obtain the author field. There are two more examples I'd like to demonstrate. So let's head back to the repository. And in this method, I would like to demonstrate using Boolean logic within our query method. So I'm going to just copy our last method, and you can see we have find by stamp author containing. So we're using the like with the wildcarded parameter. But let's say we want to pull not only one author but another. So we can add an or clause to our query method, and then we would need to traverse through the stamp once again to the author, and then we can add another parameter to specify the second author. And let's see what it didn't like. Whoops. I have two authors in my method. And one thing that's kind of interesting, I'm using STS, and in the latest version, they've built in support for Spring Data. So this interface, in reality, there is nothing wrong with it. This was perfectly acceptable to the Java compiler. But through the tolling built in Spring Data, you're seeing that it's telling me that there is no property found for stamp author author. This is very helpful. If you're thinking about using Spring Data, I would highly recommend using STS just because of the built-in tolling. You can work with it in other IDEs, but I think that's a real no-brainer with the added benefit you get there. Back to our example though, now we can pull by two authors, and it'll pull posts by either author. So let's comment out our last test. Give it a name. Once again, we will use the post repository to get a list, and now we can use our find by, whoops, and I noticed an issue. I want to add containing to the second method. So we're using the wildcarded version of the like statement for both. So let's pull for Kevin and let's pull for Rod. Okay, see if I can make this a little bit more readable. That's about the best I'm going to do. And now that we've returned those posts, let's iterate through them. So we'll get the title, and the author. We'll execute our test. There you can see we've gotten posts by myself and also posts by Rod Johnson. Just to illustrate another point with this test, if our method wasn't long enough, we can add an order by suffix to our method, and then we specify the field we would like to order by and then a direction. So here I'm saying get the posts by this author or that author and then order them by the author's name in ascending order. That's going to create a problem here. So I'll need to fix that method. You'll notice these methods do get fairly long. It doesn't help that I'm going through an embeddable, but I do think it's important to use more complex examples as we work through this. So let's execute it again, and we'll see if it orders them for us. There we see all of Rod's posts are on the bottom, all of my posts are on the top. I guess we're saving the best for last. So there we see a little bit more complexity within the query method we've defined, adding Boolean logic as well as an order by clause to the method. Let's begin working on our final example. In this example, we're going to iterate through a collection. So within posts, we have a comments field. That comments field is a list of comments, and each comment has a stamp, and each stamp has a created date. Our objective is to traverse into the comments, into the stamp, and then apply a criteria on our query for the created date. Let's head to the repository and we can begin to define this method. So as always, we start out with find by, and then we need to specify the field, and we want to head into the comments field, that list, and then within each comment we want to look at the stamp and then its created date, that hierarchy we navigated just a moment ago. And then we provide a date parameter, and at this point this will just perform an equals. However, we would like to find dates after the date specified, so we can apply that suffix. This creates one problem for us, because if we look at the relationship between comment and post, a post can have many comments. So if one of those comments meets our criteria, we're going to get that post. We're not exactly filtering by comments, so it is kind of hard to test this. To make that a little easier, I'm going to just manipulate the data some. So I'm going to set all of the authors to not included, and then I'm going to set the created date to a different date. You'll have to bear with me here. I'm not as familiar with the functions in MySQL as I am Oracle. So I'm going to set them all to the 4th month, the 4th day, and I believe I specify a string. I'm just going to cheat at this point. Whoops. Okay, now I need to add our dashes and format my date to match the format. Okay. Let's give this a go. It doesn't like, there we go. It doesn't like the way I'm trying to update all those dates. Here you see it's specifying I'm in safe mode. That's to prevent large data manipulations from occurring. So we worked around that. We do have one comment that didn't get hit. So let's just find a few. So here's post 101. I'm going to change that to included, and this is just all manipulating the data so our test works for us. Okay, I'll apply those changes. So it's likely we'll only get one post back from this if everything works well. With that done, let's head back to our test. I will comment out the old test. Make a new test. And now we'll get a list of posts. We'll use our comment, and now I'm going to use a deprecated method for the date constructor. You specify the year starting at 1900, so it'll be 1900 plus 113, and then you specify the month. So I'm going to say it is after May 1st. And actually, I believe the month in Java starts at 0. So we've retrieved our list of posts. Now we'll iterate through them. So we'll print out the title of the post. Now we'll iterate through its comments. We'll import comment, and now I gotta go through stamp. spit out the author. We'll also print out the date. Okay. And we'll also write the body of the comment to the console. Save that and we'll execute our test. Okay, and you can see that we've only got the included comments. This time they all occur after the date we've specified. So in that test, we were able to iterate or traverse into a collection, into the embeddable on that collection, and then specify some criteria on a field in the type of that collection, the comment. So it's a little bit more of a complex query. Obviously, we needed to do some data manipulation there because of the way it works. If it found one of those comments with a date after the date we specified, it returned the post, which had many comments. So there could be some issues there, mainly just the way we're pulling this in the data. So that concludes our tutorial. Just to recap, we defined 4 methods on our repository interface that allowed us to query data from our object model using various criteria and also specifying things such as order. You'll notice in this post we didn't write a single piece of JPQL, nor did we work with an entity manager, nor did we use a criteria API. And that's really the power of Spring Data. It allows us to get up and running quickly and perform some of these tasks that are pretty much boilerplate using a few lines of code. If you're interested in Spring Data, a good place to look is at their documentation. And within that documentation, they define many functions which you can use within your repositories. Here you see some of the keywords that we were specifying in those interfaces. Here you see containing, order by, after is also in this list, as well as there's a before method. So these are the strings you can put in those methods that allow you to perform different types of queries. You may want to explore that. We'll continue in our next tutorial looking at Spring Data and some other features that it does offer us. I hope you enjoyed this tutorial. This is Kevin Bowersox from the 2Thought blog.